A little bit of similarity. This time we're going to look at similar triangles. Okay, so when two triangles have the exact same three angles, we can also say that those triangles are similar. Okay, so we spoke previously in the previous video about the conditions of shapes being similar. They have to have lengths that either increase or decrease at the same rate. But also, if the shape has got the exact same angle, then if it's bigger, then one is a reduction or an enlargement of the other. And it's similar, it's mathematically similar to it. So this often happens when we have triangles that appear within parallel lines. And the last time we've seen this would have been back in first year, when we were looking at identifying the angles. Thankfully here we don't have to identify angles, all we need to do is work out the missing shapes. But when you're looking at these, it's often handy if you were to take the shapes and draw them so that you can have the shapes side by side. This is similar to the way we had it in example 1. So let's look at example 2a here. 2a, we have two similar triangles, and we've got a triangle within a triangle. So let me draw out the smaller triangle and the bigger triangle. So the smaller triangle looks like this. This length here is 16, and this is x. The bigger triangle looks like this. That's 40, and the full length here is 36. Now, I know without even saying, if it doesn't say these are similar, but I know for a fact that these are similar because the angles are totally identical. If you were to look at it, I have got an F angle here. So in my F angle, this angle here is the same as this angle here. That's what I'm marking in red. I also have an F angle on that side. So this angle here is the same as this angle here. And that's the angles that I'm marking there. So if we have a blue and the red, then the last one has to be a green angle. And the two triangles share the same bit anyway. So that there is justification enough that these two triangles are similar. So where a question maybe gets you to work out lengths in this type of triangle, it may not say that the triangle is similar. It's your job to look at the shape and realise, well, they have to be similar because they share the exact same angles. And then from here we do the exact same thing as we did in example 1. If I want to work out the value of x, the first thing I need to do is get my scale factor. So remember, the formula for scale factor is new over old. The new shape will always be the one with the x. So go to the sides that you know something about. You've got 16 and 40. So that's going to be 16 over 40. And then just simplify it down. So 16 over 40 simplifies down to give me 2/5. So this is a 2/5 reduction of the bigger triangle. So then all I'm going to do is just look at the one that we need to find. So I can say that x is equal to 2/5 of 36, or 2/5 times 36 is the exact same. So multiply it by 36 and we get 14.4. So x is going to be 14.4 millimeters. Okay. The next bit that we're looking at, we have example B. Excuse me. And again, these are similar triangles. This time we're looking at a Z angle. So, or Z and X we're having here, actually. So if we were to look at it, if you remember from your first year knowledge, this angle in here is the same as this angle in here. If I was to draw out the letter Z, means that this angle here is the same as this angle here, I'm marking with red. And if I draw out another Z, this time backwards, means this angle here is the same as this angle up here. So I do indeed have two triangles that share the exact same angles. So therefore these two triangles are similar to each other. So it's always best to draw them out side by side. So let's do that. So the first triangle is drawn here. This is 3, this is 4.5. The second triangle, you probably just need to turn it round to make it work. Let's see, we have slightly bigger. Don't worry, you don't get marks for your diagrams. So if you look at it, this side here is 3.6 and this side here is x. Okay? Just try and be careful when you're drawing this out. Draw it round so that the angles match up, and if it helps, just draw them in. So the green angle was beside the 3. The green angle was also beside the 3.6, so that's what makes them match up. The blue angles were at the top and the bottom of the triangles. The red angle was opposite from the green and opposite from the green. Mark them as new and old. So the new shape is the one with the X. The old shape is the previous one. So I can say that the scale factor is always going to be new over old. So that's good. Find the sides that pair up. So that's going to be 3.6 over 3, which is 1.2. So that means that this is a times 1.2 enlargement of the other. Okay? So let's work it out. So I can then say that x is going to be 1.2 times the corresponding side, which is 4.5. Then just work it out. So 1.2 times 4.5, and we get 5.4. So it's going to be 5.4 meters. And that is similar triangles.